Good afternoon, Sir Clint. I am Beatrice Rihas from BS32F. Together with my members, Charmy Masugud, Angela Luis Lorenzana, and today we are going to present our project entitled School Management System. Starting off, application overview. So, explain the purpose of the application. Ang purpose sa mong application is, pwede siya maka-add student, pwede siya maka-add teacher, pwede siya maka-add course, pwede siya maka-register sa mga student dito sa ilang course. Then, at the same time, it can display the student. And then, right after na to magpili sa choices, is pwede na to siya i-exit. Discuss OOP design, class, inheritance, hierarchy, and encapsulation. So first is the class. Under the class, we have 5 class. First is person, second is student, third is teacher, fourth is course, and lastly, main. So sa person, mo na siya si parent class, which is, it can represent the information for anyone in the school. Second is student, which is, it can specialize class representing as a student. Third is teacher, which is, it can specialize class representing as a faculty member. Fourth is C-course. C-course is siya si standalone class that it can handle the specific data, which is name, schedule, and teacher. Last is si main. Si main is siya ang entry point sa program that it can manage the logic and the storage or analysis. The second OOP design is inheritance hierarchy. So under that, naay superclass and naay subclass. Si superclass, mo na siya si person. Si subclass, mo na siya si student o si teacher. The third OOP design is encapsulation. Under that, we have person, student, teacher, and course. Si person, mo na siya si protected string name. Si student, mo na siya si private and student o si private string course. Si teacher, mo na siya si private string subject. Si course is, mo na siya si private string course name. Second is private string schedule. And lastly is private string teacher.
Good day, I will demonstrate our school management system developed using Java Object-Oriented Programming Principles. This application allows the user to add students, teachers, courses, and register students to a course through a console-based menu. First, I will run the program. After running the system, display the main menu where the user can choose different options such as add student, add teacher, add course, register students to courses, display students, display courses, and exit. To demonstrate the functionality, I will first choose option 1, which is add student. I enter the student's name and student's ID. The system then stores the information in array list and confirm that the student was added successfully. Next, I will choose option 2, which is add teacher. I enter the teacher's name and the subject they teach. The system stores this information in the teacher list. After that, I choose option 3, add course. I input the course name, schedule, and teacher name. The course information is then stored in the course list. To demonstrate students' registration, I select option 4, which is register student to course. I enter the student ID and the course name. The system searches for the students in the list and assign the course using the enroll course method. Next, I select Option 5. Display students. The system display all students along with their name, ID, and roll course. Then I chose option 6. Display courses. And the system prints the list of courses including the course, name, teacher, and schedule. Now, I will explain the object-oriented programming concepts are used in the system. First is inheritance. The class students and teacher both inherit from the person class using the extends keyword. This allows them to reuse the name attributes and display role method from the parent class. Second is encapsulation. The attributes such as student's ID, course, and subject are declared as private. These values can only be accessed or modified through methods such as get student's ID and enroll course, which protect the data and control how it is used. Third is polymorphism. The method display role is defined under person class but override in both the student and teacher classes. This demonstrates method overriding, where the same method behave differently depending on the object calling it. Lastly, I will demonstrate debugging and testing. During development, we encountered a compilation error called reach end of file while parsing. This error occurred because a closing bracket was missing at the end of the main class. After reviewing the code structure and adding the correct closing bracket and program compiled successfully. We also tested the input validation using the get and input method to prevent the user from entering invalid data types when selecting menu options. And that's all. Thank you.
Hi everyone, I'm Angela Luis Lorenzana, and for our school management system project, I'll be discussing the OOP principles we implemented, the challenges we faced during the development, and some potential improvements we could make to the application. Here, we have a base class called person. It contains common attributes like name that both student and teacher share. It also has a method display rule. So now look at the student class. See the keyword extend person. So this means student inherits from person. So the student class automatically gets the name attribute and can use or override method from person. But we also add student specific feature like student ID and course. So same with the teacher class, it also inherits from person but add its own specific attributes like subject. So this shows inheritance because we are reusing code from person instead of writing everything from scratch for each class. Now, next is let's talk about encapsulation, which is about protecting data. You can see here that our variables like student ID and course are declared as private. So this means they cannot be accessed directly from outside this class. So instead of direct access, we provide controlled access through public methods. For example, we have get student ID to retrieve the ID to retrieve rather the ID and enroll course to modify the course. This is encapsulation because we are hiding the internal data and only exposing what's necessary through methods. You'll see the same pattern in the teacher class with private string subject and the course class with private variables like course name, schedule, and teacher. So finally, let me show you polymorphism, specifically method overriding. So in our person class, we have method called display rule that just prints person in school. So but in the student class, we override this method using the
override annotation. Now, when we call display rule on a student object, it prints student the name instead of generic message. So same with the teacher class, we override display rule to print teacher. This is polymorphism. Now let me discuss one challenge we encountered during development and how we fixed it. Mm, One issue we faced was with input validation. When users entered letters instead of numbers for IDs or menu choices, the program would crash with an input mismatch exception. So to fix this, we created getInputs method that uses a while loop to check if the input is actually an integer. To see this condition while then ISE that has next and it keeps asking for valid input until the user enters a number. So this prevents crashes and makes the program more user friendly. Another challenge was when registering student to course. If someone entered a student ID that didn't exist, nothing would happen. The program would just continue without any feedback. So we solved this by adding a found boolean variable. So look here, we set it false. We set it false initially. After looping through all students, if we find a matching ID, we set a found to true. After the loop, we check if found and display student ID not found. So this gives clear feedback to the user. If we were to improve this application further, here are the things we could do. So first, we could add a graphical user interface or GUI. So right now, it's console-based, but using Java Swing or JavaX would make it much more user-friendly and professional using. Second, we could implement a database like MySQL instead of using array list. Currently, all data is lost when the program closes. So with database, we could save student, teacher, and course information permanently. Third, we could add more robust error handling with try-catch blocks for file operation or database connection if we expand the system. We could also add course capacity limits. Right now, there's no check for maximum student per course. So, in conclusion, this project really helped me understand how OOP principle work in practice. So, we successfully implemented inheritance by creating a person-based class, encapsulation by using private variable with public methods, and polymorphism through method overriding. So, the debugging process taught me the importance of input validation and user feedback. Thank you.